Hey everyone, and welcome to this explainer. If you're a focused learner trying to wrap your head around how to structure a really specific, highly effective developer workflow, well, you are in exactly the right place today. We're going to break down the technical architecture required to build a Quran source store, and we'll be extracting the exact building blocks you need right from today's source material.
Okay, let's dive into this. How exactly can you build an offline-capable Quran SURA store? That is the central problem our source text solves today. In software development, creating an app that just works seamlessly, even when your internet connection drops, is a massive advantage. So we're going to unpack the precise tools, languages, and methods required to actually make this happen. We'll move step by step, from the initial concept all the way to a fully resilient application.
Let's start with Section 1, Building a SURA store.
Step 1, fetch data. Step 2, store locally. To really grasp this architecture without getting totally overwhelmed, we're going to look at the individual building blocks. At its absolute core, this app relies on an incredibly simple, elegant two-part blueprint. Step 1, grab the data. Step 2, store it locally. That's the entire fundamental journey. We go from acquiring the sacred text out in the digital ether to bringing it down into the application and finally locking it safely in a vault on the user's device.
Moving right along to Section 2, Fetching with JavaScript.
JavaScript, the programming language utilized to fetch data from the APIs. Let's zoom in on that first phase. The source explicitly identifies JavaScript as the primary engine for this operation. See, rather than just serving up a static page, we rely on JS to handle the asynchronous network requests required to pull the SURA text directly into the interface. It's essentially executing the logic to make sure the data is dynamically requested and received, completely behind the scenes without ever interrupting the user experience.
Which brings us to Section 3, Connecting to APIs.
API, the external data sources holding the Quranic text that the JavaScript interacts with. So, JavaScript is doing the fetching, but it obviously needs a destination, right? That's exactly where external APIs come in. In this context, these endpoints provide the structured JSON payloads containing the text perfectly ready to be parsed by our app. Because think about it, without these external data sources, our JavaScript engine would be revving, but it would have absolutely nothing to retrieve.
Al-Quran API versus Al-Quran Cloud API. And this brilliantly illustrates the specific choices you have as a developer right now. The source highlights two distinct, super reliable options. You can use the Al-Quran API or the Al-Quran Cloud API. Evaluating which endpoint offers the best latency, payload structure, or rate limits is a really critical choice when you're plugging your JavaScript engine into these dedicated sources.
Let's move on to Section 4, Local Storage Solutions.
Local storage versus IndexedDB. Now for the second major step in our blueprint, data retention. RJS has successfully fetched the payload, but now we actually need to keep it. The crucial point here is choosing how to lock that data down locally. The source outlines two specific methods, local storage and IndexedDB. Now, if you're building this, remember that local storage is synchronous and generally capped at around 5 megabytes. That can definitely bottleneck a large text repository. IndexedDB, however, handles much larger, structured data asynchronously. It's an absolutely vital trade-off to consider when you're ensuring this data doesn't just vanish the second the user closes the app.
And finally, Section 5, the offline advantage.
The complete architecture, engine, JavaScript, data source Al-Quran API or Al-Quran Cloud API, storage vault, local storage, or IndexedDB. Let's move to and see how this builds into our complete stack, because this is the ultimate payoff. We have our engine, we have our data source, and we have our storage vault. The true power is how they interact. By fetching the data once from the API and immediately locking it into a local database, you literally eliminate the need to constantly reach back out to the internet every single time the app opens.
Offline capable application. The culmination of this entire specific workflow is a robust offline capable application. Because the data is now resting comfortably and securely on the device itself, the application is fundamentally transformed. It survives network drops, it no longer relies on a live internet connection, and it acts as a resilient tool that can be accessed absolutely anywhere.
What kind of offline app will you build next with these tools? Which leads us to a fascinating final thought. We've seen exactly how to fetch asynchronously with JavaScript from specific APIs and how to store that data locally using IndexedDB or local storage to create a highly functional Quran SURA store. But this two-step technical blueprint, it's universally powerful.
So what kind of offline app are you going to build next with these tools? The architecture is incredibly clear, and now it's totally in your hands. Thank you so much for joining me for this explainer. I hope you found this breakdown incredibly valuable, and as always, keep building.